People can use them and test them and get them on their roadmaps. Now there's a cell, it's an A sample that can be on a roadmap for a large automaker.
Owning a car will be a very different experience in the near future. Stellantis has announced all new lithium-sulfur batteries that will shake the entire EV industry. While most automakers remain tethered to conventional lithium-ion chemistries or cautiously solid-state developments, Stellantis is charting an ambitious new path in partnership with cutting-edge firms Zeta Energy and Lyten. With lighter weight, higher energy density, and zero reliance on scarce, ethically problematic materials like cobalt and nickel, lithium-sulfur batteries stand poised to revolutionize the way EVs are built, powered, and priced. And with Stellantis aiming to bring this transformative tech to market by 2030, the race to dominate the next era of electric mobility may have just taken a dramatic new turn. This is one story you can't afford to miss. Let's get started. Why do we need better EV batteries? Range anxiety remains one of the most stubborn psychological and practical obstacles standing in the way of widespread EV adoption. The fear of running out of battery before reaching a charging station, particularly in rural or underserved areas, continues to hold back a sizable portion of potential buyers. While technological innovation has made electric vehicles more capable than ever, the gap between internal combustion engine vehicles and EVs still feels wide when it comes to convenience. A gas-powered vehicle can be refueled in minutes at any of over 150,000 fueling stations in the US alone and easily travel 400 to 800 kilometers on a full tank. In contrast, the average EV range in the US sits at around 398 kilometers or 247 miles, according to the US Department of Energy. Charging infrastructure, though growing, remains patchy, a fact that reinforces consumer hesitation. Globally, the picture is only slightly better. The International Energy Agency reports that there are just over 4 million public charging points worldwide, a huge leap from the 1.3 million that existed in 2020, but still modest compared to the 1.4 billion registered vehicles currently on roads. Of those 4 million chargers, only a fraction offer the speed and accessibility necessary to make long-distance EV travel seamless. The United States, for example, has about 160,000 public EV chargers, of which only 30,000 are DC fast chargers capable of delivering an 80% charge in 30 to 45 minutes. The rest are primarily level 2 chargers, which take hours rather than minutes to recharge a vehicle. This is where better battery technology becomes not just important, but absolutely essential, and where automotive groups like Stellantis are stepping in. Stellantis, one of the world's largest automakers and the parent company of brands such as Jeep, Dodge, Peugeot, Fiat, Chrysler, and Ram, has been strategically positioning itself at the center of the battery evolution. Understanding that battery innovation is central to the mass adoption of EVs, Stellantis has committed to launching state-of-the-art battery technologies as part of its broader electrification strategy. The company's recent unveiling of a new battery platform promises to raise the stakes in the race toward high-range, fast-charging EVs. The battery Stellantis is preparing to launch is designed to dramatically enhance both range and efficiency. The promise of increased range, potentially pushing vehicles past the 700 to 800 kilometer mark per charge, means drivers may soon spend less time worrying about charging logistics and more time simply driving. Stellantis is also aiming for better thermal stability, improved cycle life, and compatibility with fast charging networks, which could enable 80% recharges in under 20 minutes. These improvements will be especially impactful in rural areas, where access to rapid charging is often limited. To support these technological advances, Stellantis has partnered with battery manufacturing giants and invested heavily in gigafactories across Europe and North America. The company plans to have 5 battery plants operational by 2030 through its joint ventures, including Automotive Cells Company, or ACC, and others. This vertically integrated strategy ensures not just supply chain resilience, but also a tailored design-to-production pipeline that allows Stellantis to tweak battery chemistries and packaging according to the needs of each brand and model under its umbrella. But battery performance isn't the only area Stellantis is addressing. It is also rethinking how batteries interact with the vehicle chassis itself. Drawing inspiration from structural battery packs like those used by BYD's Blade battery and Tesla's structural pack design, Stellantis is exploring cell-to-pack or CTP and cell-to-chassis or CTC technologies. These approaches reduce the volume and weight of inactive materials in the battery module, increasing energy density without altering the chemistry. This means a longer range without necessarily requiring larger or more expensive batteries. Still, even the best battery is only as good as the infrastructure supporting it. Here again, Stellantis is pushing forward with strategic partnerships to expand the accessibility and speed of public charging networks. In North America, the company has joined forces with 6 other automakers to establish a high-powered charging network that will include at least 30,000 chargers across key travel corridors. In Europe, Stellantis is leveraging Free2Move e-Solutions, a Stellantis subsidiary focused on energy services and smart mobility, to deploy both public and residential charging solutions. The move towards faster, smarter, and more integrated charging mirrors the approach taken by Tesla with its proprietary supercharger network, which now includes over 50,000 global stations. Other automakers like Hyundai, Ford, and BMW have also begun pursuing partnerships or independent ventures to build out EV infrastructure. Hyundai's Ioniq 6 offers ultra-fast 800-volt charging and a maximum range of 614 kilometers or 382 miles, while Ford's Mustang Mach-E achieves around 502 kilometers or 312 miles in its extended range variant. But even with these competitive models on the market, consumer surveys consistently flag charging convenience, availability, reliability, and speed as the single greatest barrier to EV satisfaction. The broader battery race is also heating up on the materials front. Conventional lithium-ion batteries, such as NMC or nickel-manganese cobalt, and LFP or lithium iron phosphate, each present their own pros and cons. LFP batteries, for instance, are cheaper and safer, though typically less energy dense. Yet companies like BYD and CATL are re-engineering these chemistries to close the performance gap. CATL's Keelan battery boasts energy densities of up to 255 watt-hours per kilogram and can deliver up to 1,000 kilometers or 621 miles of real-world range. Solid-state batteries remain the holy grail, with Toyota, Samsung SDI, and QuantumScape all pursuing the technology. The idea of a 1,200-kilometer range and 10-minute recharge is compelling, but so far, scalability and cost barriers have kept solid-state prototypes from becoming commercial realities. Until then, innovation within the lithium-ion framework, precisely what Stellantis is aiming for with its next-gen platform, remains the most practical path forward. What sets Stellantis apart is its ability to leverage a diverse portfolio of brands, each targeting different markets and customer needs, while centralizing battery innovation through shared platforms and scalable manufacturing. This means a Jeep EV aimed at adventure drivers and a compact Peugeot designed for urban commuting can both benefit from the same advanced battery technology, adjusted for performance and cost. In countries where infrastructure is still developing, such as much of Southeast Asia, Africa, and parts of South America, these advancements could be game-changing. High-range, low-maintenance batteries could drastically reduce dependence on frequent charging, enabling EV adoption even where networks are thin. Stellantis has recognized this opportunity and is tailoring its electrification strategy not just for Europe and North America, but also for emerging markets. So, what can we expect? The future of EV batteries. Now, more than ever, the race is on to create energy storage systems that are not only cheaper and longer lasting, but also safer, faster to charge, and less environmentally taxing to produce. Battery costs, once a formidable barrier to mass EV adoption, have undergone a staggering decline over the past decade. In 2010, a lithium-ion battery pack cost around $1,200 per kilowatt-hour. By 2020, that figure had plummeted to $137, and in 2023, Bloomberg NEF reported a slight increase to $139, a reflection of inflation and raw material constraints more than technological stagnation. Projections remain optimistic, with the $100 per kilowatt-hour milestone a tipping point for cost parity between EVs and internal combustion engine vehicles, expected by 2026. Some analysts even anticipate costs dropping to $70 or less by 2030, driven by advancements in materials, design efficiency, and scale. Stellantis, born from the merger of PSA Group and Fiat Chrysler Automobiles, is not sitting on the sidelines of this evolution. The company has committed over 30 billion euros toward electrification and software. Central to its strategy is battery development, where Stellantis is not only increasing its manufacturing capacity, but also investing heavily in next-generation chemistries. In 2024, Stellantis announced a breakthrough in solid-state battery technology through its joint venture with Factorial Energy. This new battery, which promises higher energy density and improved safety, is expected to be a cornerstone of Stellantis's upcoming EV lineup. Solid-state batteries differ from traditional lithium-ion cells in that they use a solid electrolyte rather than a liquid one, reducing the risk of fire while enabling faster charging and greater longevity. Factorial's proprietary FEST, or Factorial Electrolyte System Technology platform, is designed to be drop-in compatible with existing manufacturing lines, giving Stellantis a significant edge in accelerating production and scaling quickly. Energy density, the amount of energy a battery can store per unit of weight, has also been advancing steadily. Standard lithium-ion cells with nickel-manganese cobalt or NMC chemistries typically offer 250 to 300 watt-hours per kilogram. Solid-state batteries being developed by companies like QuantumScape and Solid Power aim to surpass 400 watt-hours per kilogram, and Stellantis' partnership with Factorial places it squarely within this innovation frontier. This shift could either double the range of EVs or allow for lighter battery packs with similar performance, reducing vehicle weight and boosting efficiency. At the same time, lithium iron phosphate or LFP batteries are undergoing a renaissance. Once dismissed for their lower energy densities, LFP batteries are now recognized for their stability, longevity, and cost-effectiveness. Unlike NMC or NCA chemistries, LFP cells use iron and phosphate, which are abundant and inexpensive materials, and are less prone to thermal runaway. With innovations like CATL's cell-to-pack architecture, energy densities of LFP batteries have approached 230 watt-hours per kilogram, making them viable for mainstream vehicles. Charging speed, another vital component of battery evolution, is making rapid gains. The early frustrations of EV ownership, namely long charging times, are giving way to increasingly efficient solutions. Vehicles like the Porsche Taycan already support 800-volt architectures and can charge from 5 to 80% in just over 20 minutes. Stellantis, through its partnership with Charge Enterprises and other infrastructure collaborators, is working to build ultra-fast charging ecosystems across North America and Europe. The company aims to have at least 400 fast-charging stations operating by the end of 2025. Stellantis is also addressing battery lifespan and durability. While traditional lithium-ion batteries begin to degrade significantly after 1,000 to 1,500 full cycles, modern designs are pushing this threshold to 2,000 to 3,000 cycles, translating to roughly 300,000 miles or more. Stellantis has indicated that durability will be a defining feature of its EV offerings, particularly for fleet customers who demand longevity and a low total cost of ownership. The company's battery management systems, developed with advanced thermal regulation and predictive maintenance features, are designed to optimize performance over a vehicle's entire lifecycle. Battery recycling and second life applications are also taking center stage. As EV adoption scales, the need for sustainable battery end-of-life solutions is becoming urgent. Stellantis has joined forces with companies like Orano to explore closed-loop recycling systems. By extracting valuable materials such as lithium, cobalt, and nickel from spent batteries, Stellantis aims to reduce its reliance on virgin raw materials while lowering the overall environmental footprint of its supply chain. In parallel, Stellantis is diversifying its supply chain for battery materials to mitigate geopolitical risks. The global scramble for lithium, cobalt, and nickel has exposed vulnerabilities in sourcing strategies. Stellantis is exploring alternative chemistries such as sodium-ion and silicon anode technologies, which offer promising performance without relying on scarce or ethically controversial resources. Sodium-ion, in particular, is gaining traction for grid-scale storage and entry-level EVs due to its low cost and thermal stability. Beyond personal vehicles, the ripple effects of Stellantis's battery initiatives are being felt across commercial transportation and public infrastructure. The company's Ram brand is developing electric trucks aimed at logistics fleets, while its light commercial vehicle offerings across Peugeot, Citroën, and Opel are being electrified for last-mile delivery. In partnership with Free2Move, Stellantis is also expanding its footprint in mobility as a service, where electrification is crucial to achieving lower operational costs and emissions. By 2030, Stellantis aims to have 100% of its sales in Europe and 50% in the United States comprised of battery electric vehicles. Its ambitious Dare Forward 2030 plan outlines an ecosystem that not only includes vehicle manufacturing, but also battery plants or gigafactories in France, Germany, and Italy under the ACC or Automotive Cells Company venture, co-owned with Mercedes-Benz and Total Energies. These facilities are projected to provide over 400 gigawatt-hours of annual battery capacity, serving as the industrial backbone for the company's electrified future. As the period from 2026 to 2030 draws near, the global battery landscape is poised for dramatic transformation. Stellantis, with its robust strategic investments, global manufacturing footprint, and focus on next-gen chemistries, stands well-positioned to be a major architect of this new era. Whether through solid-state batteries, LFP advancements, or ultra-fast charging ecosystems, the road ahead for Stellantis is paved with high-voltage ambition. Now, let's shift our attention to the main point. Stellantis is building lithium-sulfur batteries in partnership with Zeta Energy and Lyten. As the EV landscape accelerates toward higher performance, greater sustainability, and reduced reliance on critical minerals, lithium-sulfur battery technology has emerged as a serious contender in the next phase of battery innovation. While not yet mainstream, lithium-sulfur batteries promise substantial advantages over conventional lithium-ion chemistry, including significantly higher energy density, lower cost, and the potential to eliminate reliance on scarce and expensive metals like nickel, cobalt, and manganese. Stellantis has announced its strategic alliances with Zeta Energy and Lyten in line with its Dare Forward 2030 plan. As noted earlier, this roadmap aims for Stellantis to sell 100% battery electric vehicles in Europe and 50% in the United States by the end of the decade.
Management and vertical integration. Our manufacturing team will reduce average transformation costs by 40%.
Lithium-sulfur technology features prominently in this transition. These batteries primarily use sulfur, a byproduct of industrial processes that is abundant and inexpensive. The Stellantis-Zeta Energy partnership centers around Zeta's proprietary lithium-sulfur architecture, which uses a vertically aligned carbon nanotube or VACINT anode instead of conventional graphite. This VACNT structure allows for faster ion transport, improved conductivity, and significantly enhanced cycle life. Zeta's sulfur cathodes are also engineered to avoid the polysulfide shuttle effect, a key challenge that has historically hampered the commercial viability of lithium-sulfur batteries. This issue causes degradation in performance and loss of capacity over repeated cycles, but Zeta claims its proprietary design suppresses this phenomenon by chemically anchoring the sulfur within the cathode matrix. In recent statements, Zeta Energy reported laboratory results showing energy densities of up to 450 watt-hours per kilogram, which is substantially higher than typical lithium-ion batteries, which usually range between 250 and 300 watt-hours per kilogram. For context, Tesla's 4680 lithium-ion cylindrical cell, one of the most advanced in current EV use, is estimated to deliver around 270 to 300 watt-hours per kilogram. If these numbers scale to mass production, Zeta's lithium-sulfur batteries could extend vehicle range dramatically while reducing overall battery pack weight. The company also emphasizes that its battery uses no cobalt, nickel, or manganese, which helps reduce environmental impact and eases raw material sourcing. Lyten, the second lithium-sulfur partner of Stellantis, brings a different but equally compelling approach to the table. Based in San Jose, California, Lyten specializes in 3D graphene, a proprietary form of graphene used to enhance the performance of lithium-sulfur batteries. Lyten's lithium-sulfur batteries also eschew rare earth metals entirely and are projected to achieve energy densities exceeding 500 watt-hours per kilogram, according to internal testing. These batteries are not only lighter and cheaper, but also safer due to their thermal stability and resistance to dendrite formation, which is a cause of battery fires in some lithium-ion cells. In 2023, Stellantis Ventures, the automaker's corporate venture arm, invested directly in Lyten, signaling strong confidence in the company's R&D capabilities. Stellantis cited Lyten's potential to disrupt multiple sectors beyond just automotive, including aerospace, defense, and IoT devices. However, Stellantis's focus remains clear: to deploy this technology in its next generation of electric vehicles by the early 2030s. The Halcyon concept vehicle, unveiled by Chrysler in late 2023, featured lithium-sulfur technology in its design blueprint. Although still a concept, the Halcyon signals the company's intent to move beyond theoretical demonstrations toward real-world application. It's worth noting that Stellantis's move toward lithium-sulfur batteries comes at a pivotal time in the global battery race. Tesla, for instance, continues to push the envelope with its lithium iron phosphate, or LFP, and high-nickel cathode strategies, while also exploring solid-state and dry electrode technologies. Yet, Tesla has not publicly announced any active lithium-sulfur battery development, and the technology does not feature in its current production roadmap. Similarly, BYD, the second-largest EV battery manufacturer after CATL, focuses heavily on LFP-based blade batteries and sodium-ion alternatives for entry-level EVs. Though both companies have likely explored lithium-sulfur in R&D settings, neither has demonstrated the kind of near-term production commitment that Stellantis has with Zeta and Lyten. Other Western companies are making moves in the lithium-sulfur space, but at smaller scales. British startup Oxis Energy was once a promising name in the field, but it folded in 2021 due to manufacturing scalability issues. Scion Power in the US is also exploring lithium-sulfur and lithium-metal hybrids, and they have demonstrated 400 watt-hours per kilogram cells in lab conditions. Stellantis's lithium-sulfur ambitions also align with broader geopolitical and regulatory goals. As Europe and the US seek to reduce reliance on Chinese supply chains, especially for critical minerals, batteries that do not require cobalt or nickel become incredibly attractive. Lithium-sulfur batteries could be manufactured using domestically available sulfur and lithium, with far less need for import dependence. This advantage dovetails with the US Inflation Reduction Act's stipulations for domestic content and aligns with the European Union's push for strategic autonomy in battery supply chains. Despite the promise, lithium-sulfur batteries still face engineering challenges before they can fully replace lithium-ion in mainstream EVs. Chief among these is cycle life. While Zeta Energy and Lyten claim to have mitigated the cycle degradation issues typically associated with sulfur cathodes, independent third-party validation at commercial scales is still pending. Moreover, lithium-sulfur cells tend to suffer from volumetric expansion during cycling, which can lead to mechanical stress and eventual failure if not managed correctly. Battery management systems will need to evolve in tandem with this chemistry to ensure long-term performance and safety. Nonetheless, the trajectory is clear. Stellantis is not simply hedging its bets with lithium-sulfur. It is positioning itself as a pioneer by investing in multiple parallel technologies, including lithium-sulfur, solid-state, and sodium-ion. Stellantis is embracing the reality that no single battery chemistry will dominate every segment of mobility. By 2030, the global EV market is expected to exceed 60 million units annually. Battery chemistry will be the defining factor separating winners from laggards in this space. Stellantis, by committing to early-stage development and real-world testing of lithium-sulfur technology, is staking a serious claim to be among the winners. But we must also look at the big picture. What are Stellantis' competitors doing? As the global EV revolution gathers momentum, the battle for battery supremacy has become fiercer than ever. While CATL continues to dominate the EV battery market with a 38% share, competitors across the globe are accelerating their innovation strategies, investing in next-generation chemistries, manufacturing capacity.
Incentives offered to improve manufacturing capacity. It says over the last 3 years, the number of applications.
And new paradigms like battery swapping. For instance, BYD's Blade battery, with its lithium iron phosphate chemistry, has gained traction for its safety and thermal stability. It's become the go-to choice for customers prioritizing reliability and affordability, particularly in markets like Southeast Asia and Latin America. In contrast, LG Energy Solution is targeting high-energy density applications, advancing solid-state and high-nickel chemistries. The South Korean firm has expanded aggressively in the US, building new factories in Michigan, Arizona, and Tennessee, in part to benefit from incentives under the Inflation Reduction Act. LG remains a critical supplier to Tesla, GM, Hyundai, and Volvo, reflecting its multifaceted approach to battery development. Panasonic, too, is investing heavily in improving its 4680 cylindrical battery cells, which promise more efficient energy storage and reduced cost per kilowatt-hour. Though Tesla has diversified its supply base, Panasonic continues to be a vital partner in North American production. The Japanese firm is focused on optimizing cell design for faster manufacturing and better thermal performance. Panasonic's long-term goal aligns with making batteries not only higher performing, but also easier to produce at scale, which is crucial for global EV adoption. On the cutting edge of battery science, QuantumScape, with backing from Volkswagen and other investors, has produced solid-state prototypes that boast fast charging and exceptional energy density, although commercial readiness remains a few years away. Its solid ceramic electrolyte addresses many of the flammability and degradation issues of current lithium-ion tech, but QuantumScape must now turn lab breakthroughs into scalable products. Across the Pacific, China remains a dominant hub, not only for battery production, but also for pioneering new business models. The rise of battery swapping in China is especially noteworthy. Companies like NIO have built out an extensive network of over 2,300 battery swapping stations, enabling users to replace a depleted battery with a fully charged one in under a minute. NIO has already completed over 40 million swaps and is expanding the model into Europe. Geely and Alton are following suit, with Alton constructing hundreds of stations and forming partnerships in Southeast Asia and the Middle East. This infrastructure-first approach reflects a broader Chinese strategy: create an entire ecosystem around EVs that reduces downtime and dependency on charging infrastructure. Stellantis, while not yet fully invested in battery swapping, has expressed interest in alternative approaches to battery ownership and lifecycle management. Through its free-to-move mobility platform and global partnerships, the company is exploring flexible battery subscription models and second-life battery applications that could complement its solid-state ambitions. The race to dominate the EV battery space is no longer just about chemistry or capacity. It's about who can integrate innovation, supply chain security, environmental responsibility, and consumer usability into a scalable product. While CATL, with its massive scale and early mover advantage, remains the top player globally, the gap is closing. As more automakers invest directly into battery R&D and production, the power dynamics of the EV industry are shifting. Stellantis no longer wishes to be merely a customer of battery suppliers. It aims to be a competitor, an innovator, and possibly a disruptor in its own right. And it can indeed carve out a niche for itself. Why Stellantis stands to outperform other EV brands. With deep brand diversification, aggressive technological bets, strategic supply chain maneuvers, and unique positioning in underserved vehicle segments, Stellantis has laid the groundwork for sustainable growth where other automakers either struggle to pivot or remain narrowly focused. Stellantis's diverse portfolio of brands gives it a unique ability to capture niche markets globally. From Peugeot, Citroën, and Opel in Europe to Jeep, Dodge, Ram, and Chrysler in North America, and Fiat in Latin America, Stellantis commands a breadth of consumer identity that few automakers can replicate. This gives Stellantis a tactical edge in rolling out EV platforms tailored to regional needs. For example, while Tesla builds largely homogeneous offerings across markets, Stellantis can deploy compact, city-oriented EVs in Europe, such as the Peugeot E208 or Opel Corsa Electric, off-road hybrids under Jeep for North America, and affordable small EVs for emerging markets through Fiat. In the US, where pickup trucks and SUVs continue to dominate, Stellantis holds a trump card that few EV manufacturers can match: the Ram and Jeep brands. Tesla has no presence in the rugged utility segment beyond the Cybertruck, which remains an unconventional choice for traditional truck buyers. Rivian has attempted to crack this space with the R1T, but its high price and luxury appeal make it a niche product. Stellantis, on the other hand, is preparing to launch the all-electric Ram 1500R EV and the Jeep Recon, both of which promise to bring EV capability to the mainstream utility vehicle space. The Ram REV, expected to offer up to 500 miles of range with an optional 229 kWh battery pack, speaks directly to a segment that demands durability, hauling power, and long-distance confidence. With a loyal customer base and established distribution network, Stellantis stands a strong chance of converting traditional truck buyers to EVs. Unlike any other brand, technologically, Stellantis's bold investments in non-mainstream battery chemistries could prove to be a game-changer. While most automakers are focused on perfecting lithium-ion variants or waiting on solid-state technology, Stellantis is one of the few aggressively exploring lithium-sulfur through partnerships with Zeta Energy and Lyten. These batteries promise higher energy density, lower environmental impact, and zero reliance on cobalt or nickel. This gives Stellantis a long-term strategic advantage in both sustainability and supply chain resilience. Lithium-sulfur batteries are lighter, cheaper, and can be produced using more readily available materials, which could prove decisive as global tensions and regulatory bottlenecks continue to impact the availability of critical minerals. While Tesla and BYD boast advanced battery tech, neither is currently developing lithium-sulfur for EV production at the scale Stellantis is planning. This first-mover advantage could give Stellantis superior range per cost metrics, especially in high-demand commercial segments where vehicle weight and capacity matter. Stellantis also distinguishes itself in the EV race through its highly modular STLA platform architecture, covering everything from compact cars to full-size trucks with just 4 scalable platforms, allowing for cost-effective, flexible production across diverse markets. Unlike Tesla's bespoke vehicle architectures or Volkswagen's narrower modular range, Stellantis's approach enables rapid pivots in response to shifting global regulations and incentives. It also strategically targets underserved EV segments, especially affordable urban mobility in Europe and Latin America, with models like the Citroën EC3 and a planned €20,000 EV, markets where Tesla still struggles to compete. Moreover, Stellantis dominates Europe's light commercial vehicle sector through its Pro One initiative, offering electric vans tailored to urban delivery needs, far ahead of competitors like Tesla and BYD. Stellantis is also investing over €30 billion into electrification and localized supply chains, building gigafactories, and securing raw materials via ventures like Automotive Cells Company to minimize reliance on Asia and future-proof its operations against tightening trade and compliance rules. Finally, Stellantis's bold commitment to software-defined vehicles and AI-backed infotainment systems gives it a futuristic edge, often overshadowed by Tesla's dominance in this space. Through its STLA Brain and STLA Smart Cockpit platforms, the company is developing a cohesive digital ecosystem that merges navigation, entertainment, diagnostics, and over-the-air updates across all brands. Working with partners like Foxconn and Amazon, Stellantis plans to roll out vehicles with real-time AI assistance, personalized driver profiles, and dynamic energy management. This is history in the making. The EV arena will never be the same again. Well, that's it for now. Thanks for watching. Did you like this video? If you did, please consider liking, dropping a comment, and hitting the subscribe button so that you don't miss out on our new uploads. Also, don't miss this video you see on your screen right now. It's truly unbelievable.